Okay, so I'm doing my equilibrium question because I skipped it by accident. So this is 2003 B, and here we go. So they give you the reaction 2HI is reversible and goes to H2 plus I2. And the first question says after, okay, so, and then it says after 1 mole sample of HI is placed into an evacuated 1 liter container at 700 Kelvin, the reaction represented above occurs. The concentration of HI as a function of time is shown below. And then the first question says, write the expression for the equilibrium constant, Kc, for the reaction. And so I put Kc equals concentration of H2 times the concentration of I2 over the concentration of HI to the second. And then it says, what is the concentration at equilibrium? And if you look on the graph, it says 0.8 molar. The third question is determine the equilibrium concentrations of H2 and I2. So what I did for this is I made a nice chart, and I plugged in the initial, and then I looked at the graph, and yeah, so there you go. Plugged it all in, and I got I2 is equal, concentration of I2 is equal to the concentration of H2, and that equals 0.10 molar. Then D says, on the graph above, make a sketch that shows how the concentration of H2 changes as a function of time. So I just sketched a graph showing when if you start from 0, showing the time of when the reaction reaches equilibrium. So I started from 0 and I did that. Yep, okay. So E says calculate the value of the following equilibrium constants at 700 Kelvin. So I started with the expression, and then I just plugged in the numbers that I found in my ice chart, and got 0.016. And then for Kp equals Kc, so because the moles are equal to the moles in this reaction, so it's 0.016 for Kp. F, it says at 1000 Kelvin, the value of Kc for the reaction is 2.6 times 10 to the negative 2. In an experiment, 0.75 mole of Hi, 0.10 mole of H2, and 0.50 mole of I2 are placed in a 1 liter container and allowed to reach equilibrium at 1000 Kelvin. Determine whether the equilibrium concentration of Hi would be greater than, equal to, or less than the initial concentration of Hi. Justify your answer. So this is where we deal with Q. So I did Q equals the expression that I've been using, and then I plugged in the numbers, and I got 8.9 times 10 to the negative 2, and then Kc is equal to 2.6 times 10 to the negative 2, and so Q is greater than Kc. So to reach equilibrium, the numerator must decrease and the denominator must increase, so Hi will increase. So there you go.